I labeled what? I labeled, no. Oh, because it's frozen, because Miss Sterling's an idiot. I labeled I or D. I is with replacement, D is without. Independent, dependent. I need y'all to pay attention. That's the last time I'm going to say it. Okay. I have two things happening here. I want to flip a heads and then I want to flip another head. Raise your hand and tell me what's the chance of getting head.
1/2. Nobody
raised their hand, but I heard people talk. Yes, sir. What's the chance of getting heads? 1/2. What's the chance of getting heads on the second flip? Yes, sir. Wait, pause. I want to get a head again. What's the chance of getting heads on the second flip? Yes, 50, a half. Now I want to know the combined or the compound probability because I've got two events happening. So what do I do with the half and a half? Multiply. Now it's time for your 25%. Half of a half is 1/4. Is 25% is what as a decimal? What's this as a decimal? As a decimal. 0.25. All right, thank you. Okay, there are 3/4, 5 dimes, and 2 nickels in a jar. What's the probability of getting a dime and then a dime without replacement? I'm multiplying. How many dimes? Excuse you. What's the chance of getting a dime first? Hand. Nobody should be talking unless they're answering this question. Yes, you raise your hand first. 5 out of 10, because that's my dime. Now, I want a dime without replacement. Stop cheating and look at my notes that I already did. I've taken out a coin. Do I still have 10 coins at first?
Oh, you got 4
I have 10 at first, and then I have 9 later. So, 9 is my new denominator, and I took out a dime. Do I still have 5 dimes? I have 4 dimes. 5 tenths times 4 ninths is what? What's 5 times 4? And what's 10 times 9? What can I do to simplify? By 10. Cross out the zeros. What's left? 2 ninths. Good. And what would this be as a decimal? What'd I tell y'all about the ninths? Yes.
0.22.
0.22 repeats. And what would this be as a percent?
So 2200.
No, not 100. There's no 1 here. And there would be a decimal over, or a whole number over here.
22.
22.2% repeats.
I don't even got that on paper though.
Okay. I am rolling a 6-sided number cube and flipping a coin. What's the likelihood of getting a 3 first, then a tail? Hands. I want to know what's the likelihood of getting a 3. It's somebody from beside this table that has my notes already from another class. Somebody else. I need y'all to pay attention. If you about to talk, you need to be talking to me. Okay, let me do it this way. What can I get on a number cube? 1 through 6. What's the chance of rolling a 3? I need a hand. Yes. 1 out of 6. What's the chance of flipping a tails on a coin? 1/2. 1 out of 2. 1 out of 2. 1 out of 2. What do I do with these two fractions? 1 times 1. 1/12. I'm not going to break this one down. I'm just going to do the easy ones as far as fractions, decimals, and percent. Okay, I have those same 3/4, 5 dimes, and 2 nickels. How many coins was that from number 2? 10. It says without putting it back. So I'm going to start with 10 as my denominator. And then what's going to be my denominator in my second fraction? 10 first, 9 second. Okay? So I want a nickel first. What's the chance of getting a nickel? Hand. Bam. 2 out of 2/10.
Ow.
What's the chance of getting a dime after I've taken out a nickel? Hand. Yes, ma'am. Over there.
Yeah.
Good. Multiply. Top times top, bottom times the bottom. 2 times 5. 10/90ths. What will this simplify to?
Carly.
1/9. What would this be as a decimal? Nope. Go back to this one. What was this one? So this is point what? This was point 2 repeating. Point 1 repeating. And what would it be as a percent? All right, so looking at number 6 on the first compound probability problem. You have a bag of 17 colored chips. 4 are blue, 6 are green, 2 are red, and the others are yellow. What's my total? It's not a trick question. It's at the first sentence. Thank you. 17 is my total. If 4 are blue and 6 are green, how many is that so far? 10 plus 2. 12. And then I need to get to 17. So how many are yellow? 5 are yellow. What is the probability of drawing a blue chip, replacing it, and then drawing a yellow chip? Remember, if I replace, that is independent. If I don't replace, so without replacing, it affects the future events, which means it's dependent. Make sure you have that written down. Okay, ladies and gentlemen, real quick. The purpose of my giving you notes and showing you all of this is so that you can follow suit. That means do what Miss Starling did. Does it make sense for you to just write the answers down? Okay. Just putting that out there as a rhetorical statement. I heard somebody's phone go off. They need to be turned off. I've already taken one phone today. I'm going to start collecting phones in a bucket. Just turn it off. And then if it goes off when it's in my possession, I will send it to the front office and you can pay $15 to get it back. Just turn them off. That's what that means. Yes. Okay, so back to my question. I want a blue chip and then a yellow chip. And I am going to replace it. So is it independent or dependent? It is independent. Good. How many chips do I have altogether? 17. So what are my denominators going to be if it's independent? Do they change or stay the same? Stay the same. Good. 17 and 17 is my total. How many blue chips are there? And how many yellow chips are there? Great. 4 5 17ths and 5 17ths. Now I'm going to multiply. What's 4 times 5? 20. What's 17 times 17? 60. Way more than 60. 289. Too much. Take 100 away. 189. 289. You took 200s away. 289. There's my final answer. It cannot be simplified. 7. What is the probability of rolling a 3 on a 6-sided number cube and then not rolling a 3 on a 6-sided number cube? So whenever they say the word not, they're talking about a complement. Okay, so these are complementary. Huh? 17 times 17. Let me double check. 7 times 7 is 49. 7 times 1 is 7 plus 4 is 11. 1 times 17 is 17. 9 plus 0 is 9. 1 plus 7 is 8. 1 plus 1 is 2. 289. Did you carry a 1 right here where you added 7 and 1? You didn't need to carry a 1 over here. Do you want me to check on a calculator? Because I can if you don't believe me. Okay. Thank you for trusting in your teacher. So this is complementary, meaning I'm going to have two fractions that make a whole, but I'm not going to add them. I'm going to multiply them still. Watch what I do. So I want a 3, and then I want not a 3. Probability of 3, then not 3. What can I get on a number cube? 1, 2, 3, 4, 5, 6. What's the chance of getting a 3? 1 out of 6. Thank you for not saying 3 out of 6 because there's only 1 3 here. There aren't 3 3s. What's the chance of getting not a 3? 5, because everything else is the 5 numbers that are left. So I have 1 plus 5 would give me 6 out of 6, which makes my whole, which is why it's complementary. But I'm going to multiply because that's what I'm supposed to do for compound probability. 1 times 5?
6.
You're adding. I'm tricking you. And 6 times 6?
6.
Okay, if I roll a number cube, is the first roll going to affect the second roll? No. So because it does not, it is a what kind? Independent or dependent? Independent. Independent. Dependent is if it changes. So that's without replacing. Can I replace the side of a number cube? No, because I can't take one off. Okay, huh? I can't take a side of a number cube off. Okay, realistically speaking, without being foolish. All right, using the spinner from number 5. What is the probability of spinning a negative number then a positive number? So is this independent or dependent? Remember, it's a spinner. Independent. Negative first, positive second, independent. How many negative numbers are there? How many? 2 out of, I'm looking right here, guys. Negative, negative. 2 out of what? 10. Count those pieces, man. 2 out of 8. How many are positive?
6.
How many?
6
out of 8 are positive. These are another set of complements. Two 8s times 6 8s. What can I do with them? Multiply them, but before multiplying them, simplify. What's 2 8s reduced? 6 8s reduced. 3 4s. Remember, they got to stay complements. So 2 plus 6 is what? Listen. 2 plus 6 is what?
8.
1 plus 3 is what?
4.
Okay, as long as I'm getting the denominators, I'm good. Now multiply. 1 times 3?
3.
4 times 4?
16.
3/16 is my probability of spinning a negative number and then a positive. I cannot simplify 3 and 16 because the only factor they have in common is 1. All right, back here, we need to identify independent or dependent.